In this worked example, we have three forces acting in opposite or in different directions, and we need to find the resultant force and the direction of motion, right, in order to calculate the acceleration. So we aren't given any information to allow us to assume which direction acceleration is, and we have more than two forces, and so in order to find the resultant force, the net force, we need to split all these forces up into their different components and resolve horizontally and vertically in order to find the net force. So we're going to draw our resultant force off on the side here. Right, we don't want to do it on the actual diagram so that we don't get confused. So we first need to find our vertical and horizontal forces, and to do that we need to go to the original diagram and look at the forces that we're given. Now, two of the forces are not going to have components. One is vertical, the 2 newtons is just going to be a vertical component, and the 4 newtons is also just going to be a horizontal component. The only one that we're going to have to split up into its components is going to be the 3 newtons. So it's going to have a vertical component, and it's also going to have a horizontal component. Right, now it's important that we keep track of the direction of these components, right? Because when forces act in opposite directions, we need to take that into account. So this is going to be the vertical component, and this is going to be the horizontal component. Right, the angle given is 30 degrees. And based on the fact that these are parallel lines, this is also 30 degrees because it is an alternate angle. So that very easily allows me to work out the x and the y components. Okay, I'm going to add all my forces together for the vertical components, right? And I'm going to consider the direction that they're acting in. So we have 2 newtons acting in a vertical direction, right? We don't have to split it up because it is already vertical. And then we have this y component of the 3 newtons, the vertical component, but it's acting in the opposite direction to the 2 newtons, right? So it's a negative. All right, what is that force? Well, it's the opposite side to 30 degrees, so it will be 3 sine 30 degrees. Okay, well, fortunately for us, sine is, well, 30 degrees is just going to be a half. That works out nice, but in any case, we're going to have 2 minus 3 sine 30, and that's going to give me a half. Now we just need to look at the horizontal components. So the horizontal components, they're both acting in the same direction. So we're going to have this 4 newtons, all right? This 4 newtons is this horizontal force here. It doesn't have a vertical component. And then we also need to consider this horizontal component from the 3 newtons, okay? That is the adjacent side in my triangle. So it's going to be 3 cos 30 degrees. So we're going to have 4 newtons plus 3 cos 30 degrees. That's going to give me 8 plus 3 root 3 over 2. All right, obviously we don't want to simplify too early because we want to be able to get the exact value of my resultant force. If we round off now, we will lose some of that values, all right? And we're going to find the angle, and the angle relies on us using the tan ratio, so we want to use the exact value in our calculator. So either store it or just keep it in the memory for now. Okay, now that we've calculated the two, the horizontal and the vertical force, we're now ready to find the resultant force. That's just the hypotenuse of this right angled triangle. So I can say that f is equal to the square root of f of x the vertical or the horizontal component squared plus the vertical component squared. So I'm just going to put those values in. So f is equal to the square root. Right, what is the vertical component? Is just a half squared. And I'm going to add this to this 8 plus 3 square root 3 over 2 all squared. Okay, now I still have that in my calculator, that 8 plus 3 square root 3, 2 squared. And so the first thing I'm going to do is I'm going to square it. And I'm going to add that to a half squared. So that's going to give me f equal to the square root of 23 plus 12 root 3. And I need to take the square root of that. And that's going to give me f equal to, the force is equal to 6.61. Oopsie, we don't want to circle 6.16994, etc. Right, we're going to round to 3 significant figures. So the force is equal to 6.62 newtons. Right, I also want to find the angle. All right, so I want to find this angle here above the x, or the positive x-axis, right? That's the tan ratio of the two sides. So I can say that tan of theta is equal to my opposite, which is my vertical component, over my horizontal component. So let's put our values in. Tan theta is equal to a half over 8 plus 3 square root 3 over 2. Okay, I need to take the tan of that, and this is where having the exact value from your calculator in, you don't have to go resolve that, or you can go and resolve that. So we could just go 4 plus 3 cos 30. That will put again into my calculator 8 plus 3 root 3 over 2. We want that 0.5 to be divided by that. And now we want to find the tan. So we'll go tan inverse. And that's going to give us theta equal to 4.333. This is degrees, so we want to round to 1 decimal place. So we'll get 4.3 degrees. Right, so returning back to the question, we were asked for the direction of the subsequent motion and the acceleration. Okay, so we have the force in the direction of motion now, and so we can use that to calculate the force. So we're just going to use Newton's second law. Force is equal to mass times acceleration. Okay, the force is the force that we've calculated, 6.62. The mass of the object is 3 kilograms, and we want to work out the acceleration. Okay, so that gives me an acceleration. Right, again, you would have had to save the value in your calculator. That's going to give me 2.205, etc. We want to round to 3 significant figures, so that will give me 2.21 meters per second squared. So the acceleration is at 2.21 meters per second squared in a direction 4.3 degrees above the positive x direction.